Good morning, statistics. It's Monday. Today we are going back into our 3.2 notes, so go ahead and open those up. And we are starting on a new thing, which is called inverse normal. So if you scroll down to this page, it talks about what inverse normal is and how to put it in. The purpose of is it will help you find the exact number underneath the curve for a certain percentage shaded. You did a couple of problems like that last week, but you had to guess and check. So like this example here, if we want to know what score we need for the 90th percentile, there's an actual function for that. Okay, so for like this example, we can find this x value with this percentage shaded. And we can find this x value when we know that this percentage is shaded, whether it goes to the left or the right. And we can also find the two values if we know the center portion that is shaded. It's all about what setting you use on your calculator. Okay, so we're going to scroll down and look at these examples. Okay, so we've got Tiger hitting the ball with a mean of 304, standard deviation of 8, and he wants to know what percent of the drives are at least 290. So if I'm going to sketch the curve, I know my mean is at 304, and I want 290, and I want the percent of drives that are at least 290, so we're doing 290 and above. So I'm actually looking for the percent, sorry, I'm shaking, the percent that's shaded here, not the x value. We know the x value. So this is a normal CDF problem. Lower bound is 290, upper bound is infinity, mean is 304, and standard deviation is 8. So that's still in the same menu on your calculator, the distribution menu, normal CDF, or if you're using StatWeb. So go ahead and calculate that out. For number 5, we're looking for between 305 and 325. So we're looking for the percent in here. So again, we know these x values. So this is still a CDF problem, except this time we have a lower and an upper bound. Okay, so go ahead and calculate that one out. 6 is when we finally get into, use the inverse normal. What distance would the ball have to travel to be in the 80th percentile? So 80th percentile means that you are doing better than 80% of the population. So we know that 80% is shaded, and we are trying to find that x value. So this one is called inverse normal. Okay, so first I'm going to show you how to do it on the TI-84. All right, it's the same menu as normal CDF, second distribution, except it's option 3, inverse normal. The area that is shaded is 80%, but remember, I'm going to change that to a decimal, so its area is 0.8. The mean was 304, and the standard deviation was 8. Now here, left tail, center tail, or right tail. Look at the picture. The tail is going to the left, so we want a left-hand tail. Okay. All right, so then you can see the coding right here. We've got 0.8, 304, 8, and left-hand tail, and we have an answer of 310.7. So the percent shaded is first, the mean is second, and then the standard deviation is last. So our x value down here is 310.7. So you would have to get a 310.7 to be at the 80th percentile. Now, let me show you in Statlet. instead of calculating the area under the normal curve, we want to calculate a value corresponding to an area. Mean is 304. Standard deviation was 8. Isn't that nice? They graph it for you. We wanted a left-hand tail with a boundary of with an area of 0.8. So good. So they calculate 80% of that data is over there on the left, going to the left-hand tail. So that cutoff value is 310.7. Take a look at what it looks like if it was a right-hand tail. It's just flipped. So this would actually be the 20th percentile mark because 20% is to the left. And if we do a center, it gives you two values. It gives you the lower bound of that central group and the upper bound. Let's take a look at example 7. What distance would the ball have to travel to be better than 25% of Tiger's drive length? So, better than 25%. So that means 25% is over here. So the question is, what value would he have to be? So this is just the 25th percentile. So we got inverse normal of 0.25, 304, 8. Let's see how I can step with this time. So 304, 8. That was a left tail because I shaded it myself. Alright, so this time I've got 298.6. So as long as he does better than 299 or better, then he's going to be above 25% of his normal drive length. This time it looks like this is 3.2 worksheet 1. It's going to use a couple of things we've done before. It's going to use the 68, 95, 99, 7 rule. It's going to use normal CDF. And at the very end, it's going to throw in some of those inverse normal problems that we just learned today. So a lot of this stuff is older. So think back, scroll through your notes. And I will see you the last 10 minutes of class.